Every incredible building you've ever seen, from a towering skyscraper to your own home, it doesn't start with a brick or a beam. It starts with a plan. And it's way more than just a sketch. It's a universal language, a detailed script that everyone on the job has to understand perfectly. But what happens when that language gets misinterpreted? So picture this. You're on a busy construction site. The plans say a huge air conditioning duct has to run right here. But a different set of plans says a critical, load-bearing steel beam has to go in that exact same spot. Now what do? Well, that's what the industry calls a clash. And it's not just some small oopsie. It's a potential nightmare. It can stop a project dead in its tracks for weeks and cost a fortune to fix. This is the exact kind of chaos that a perfect set of construction drawings is supposed to prevent. Right, so these clashes you see on site, they're really just the final symptom of a problem that started way earlier, as a simple conflict on paper, a total disconnect between different sets of plans. And this is where construction drawings are supposed to be the hero. You gotta think of them as the ultimate instruction manual. They're the graphical language that makes sure the designer's vision is communicated with absolute clarity to every single person who's gonna build it. But this language has a few different dialects, and each one tells a very specific part of the building's story. Let's break down the main ones. Okay, so first you've got your architectural drawings. This is the big picture, the look and feel, the floor plans, how it all flows. Then you've got structural drawings. This is all about the building's skeleton, the beams, the columns, the foundation that holds the whole thing up. And finally, you have MEP drawings, which map out the building's entire nervous system. It's mechanical, electrical, and plumbing. Each one is its own world of crazy detail. And just look at the level of precision we are talking about. This right here is a reinforcement drawing. It's not some rough idea of a concrete beam. It is a hyper-detailed schematic telling workers the exact size, shape, and placement of every single piece of steel rebar inside. Every single line, every number you see here has a critical structural meaning. So you've got all these incredibly detailed, separate plans. The architect has theirs, the structural engineer has theirs, the MEP team has theirs. Now comes the hardest part. It's not just making the lines on the page match up. It's making sure all the teams are communicating in perfect harmony. Let's just take the MEP process for a second. It's not one step. First, an engineer designs the system. That's the logic. Second, a drafter turns all that logic into technical drawings. But the most crucial step? It's the third one, coordination. This is where all those drawings are digitally stacked on top of each other to find those clashes before anyone even breaks ground. And this really hits the nail on the head. You have brilliant people in different teams, often in different offices, all making their own perfect plans. But when they're working in a silo, it is almost guaranteed that a pipe is eventually going to get designed to run right through a structural beam. All right, so once the plans are coordinated, we move from the what to the how. The big picture designs have to be translated into super specific, buildable instructions for the people actually making the parts. And this brings us to a really important distinction: design drawings versus shop drawings. The design drawing, that's the architect showing the vision, the intent. But the shop drawing, which is made by the contractor, that's the detailed recipe. It tells the workshop exactly how to cut the steel and assemble the ductwork with millimeter precision. And believe it or not, the drawing lifecycle doesn't end when construction starts. Small changes always happen on site. It's just a fact. So the final step is creating what are called as-built drawings. These are the original plans, but updated to show exactly how the building was constructed, with all the little tweaks included. This final record is absolutely vital for any future maintenance. So when you put it all together, you've got multiple teams, tons of different drawing types, constant revisions. You can start to see how easily things can go wrong. I mean, the sources of error are just endless. You can have incomplete details, uncoordinated plans, or even those simple, mad-editing mistakes like doors that are drawn to swing open right into another door. Just having inconsistent revision numbers alone can cause a team to build from an outdated plan, leading to a ton of expensive rework. So when you step back and look at all this, the real problem becomes crystal clear. The biggest challenge in modern construction isn't a lack of skill. The real bottleneck is managing the constant, complex flow of information. At its heart, it's a giant communication problem. Which leads us to the ultimate question, right? With dozens of people involved and hundreds of drawing revisions flying around, how do you make absolutely sure that everyone on that site is working from the single, most up-to-date version of the plan? Well, the old answer to that question has always been kind of messy. It's usually a patchwork of outdated spreadsheets, never ending email chains, and those chaotic WhatsApp groups where the latest version of a critical drawing can just get totally lost. And that's exactly where modern tools come in. A platform like Lementai.com is designed specifically to solve this communication breakdown. It digitalizes the entire workflow, creating one single source of truth so that every single person has access to the right information at exactly the right time. It's really all about bringing order to that information chaos. You can actually see how it works and start for free today over at Lementai.com. This explainer on the universal language of construction was brought to you by Lementai.